Good morning, friends. In continuation of my previous lecture about metallic coating, today we'll continue the another methods of applying metallic coating. So first we'll go for the galvanizing. As this galvanizing is a electrochemical plating of a high corrosion resistant material on the surface of another metal, and in this process, applying a zinc coating to the steel or iron components for the prevention against the rusting. And again, our object is to improve the corrosion resistance. Okay, and this galvanization process consists of the four fundamental steps. Okay, first one is the surface preparation, then second is the pre-fluxing, then the next one is the galvanization, and last one is the finishing. So in this diagram I have shown the this all four steps of galvanization. Okay, so look at in this diagram I have shown the all steps. Okay, and this technique is widely used for the coating a zinc over the iron and the steel also, and galvanized sheet metals are available in the market for their commercial use also, and this technique is very popular and widely accepted due to its effectiveness and economy. There are the various methods are employed for galvanizing of zinc to the metal substrate. So one by one we'll see the different methods. First is the hot dip galvanizing. The first step of this process is cleaning of the workpiece, that involve its degreasing by acid rinsing followed by the water cleaning. Okay, and the second is it's annealing and the cooling in a oxide free atmosphere. Okay, and then during the cooling, when temperature of workpiece reaches near to the temperature of the molten zinc bath temperature, and then workpiece is dipped in the bath. Okay, and very thin and uniform coating layer can be maintained by passing the sheets through the roller just after the coating. Okay, and this method is not recommended for the galvanizing of very delicate and complex shaped parts having the complex interior design. So this is one disadvantage we can see. And here in this figure I have shown the process of hot dip galvanizing. Let us discuss the next one, shearodizing. Okay, and this process is used for the galvanizing of those small particles having the intricate shapes. Okay, and in this process there is a box or container having the filled with fine zinc powder, and the parts are placed in this box surrounded with the powder. Okay, and the box is then heated in a oxygen. Zinc powder then vaporizes, and zinc vapor comes in contact with the surface of the workpiece, and the zinc is deposited on the workpiece. Okay, and then workpiece is then taken out of over, and it is allowed to cool down to the room temperature, and in this way galvanization of the workpiece can be completed using this shearodizing process. Let us discuss the electroplating galvanization. In the case of electroplating galvanizing, zinc is deposited onto the workpiece by making it as a cathode. Okay, and it is just like an electroplating process. Working of the electroplating, as already I have discussed, and this process is time consuming, so it is not recommended for the mass production. Thickness of the coating layer is very thin, so it is not capable to provide corrosion resistant property to the workpiece. So this is about the electroplating galvanizing. So let us go for the last galvanizing process, that is a cold dip. So this process involves cleaning, buffing, degreasing of the work surface before the galvanizing, and the cold bath is used in this process. No heating of a flow of current through the electrolyte solution is required. So the cold bath is preferred by dissolving shafts like zinc chloride, tin chloride, ammonium chloride, and potassium betatrate. Okay, so in water, and it is filled in the tank, and the tank used in this process is a metallic tank carrying a thin lining of the rubber or PVC sheet on its internal surface. Okay, and during the preparation, proportion of the thin chloride should always be less than half of the quality of the zinc chloride. So this care we have to take during this process. Let us go for the next one is the anodizing. Anodizing is a process of depositing oxide film on a metal surface with the help of anode and oxidation, and the process involves cleaning of the workpiece either in the hot soak cleaner or in a solvent bath. And after cleaning the workpiece is deposited in an electrolyte and made as an anode, and the electrolyte used should give up the oxygen on electrolysis, and there is no any deposition from outside. When current passes through electrolyte, a chemical reaction takes place and oxygen is liberated, which reacts with the metal surface to convert it into the oxide. Okay, and in this process the reaction progress inwards into the metal, and the coating deposited is the integral part of the metal itself. Okay, and the deeper the penetration of the chemical reaction, the thicker will be the oxide film formed. Okay, and after the formation of the oxide layer into third stage of the process is provided desirable color and stability to the anodizing film. Okay, and the color of the deposited layer, it's depend upon the selection of the acids as an electrolyte. Sulfuric acid provide a thin transparent film over the metal surface, and the anodized metal exhibit its own natural color after the process. And chromic acid can also be used as an electrolyte to deposit oxide layer, and it provide milky white color to the surface, and that can also be changed to gray color depend upon the variation of the bath temperature. Copper and its alloys are not anodized by this bath. Oxalic acid bath can be provide a oxide film of a light yellow color, and thickness of the coating depends upon the concentration of the bath, in density of the current passing through the electrolyte, and its temperature. Okay, so the porous deposition can also be sealed by applying oil of wax to it. Okay, and anodizing of different types of metal are possible, and some of the useful commercial examples I have discussed here. The first one is the anodizing of steel is done to make its wear and corrosion resistant. It appears as a block film over the different type of steel. Then several galvanized machine parts are anodized to improve their resistance for rusting and corrosion. Okay, and the main purpose of the anodizing also I have discussed here. So it provide protective coating on the metal surface, which is corrosion resistance and wear resistance. Okay, up to the some extent, and to provide a decorative appearance to the surface also we can use this, and it can provide a specific color based to the surface that can be substituting of the painting. Okay, and then aluminum provides very good surface property after anodizing. Okay, this is about the anodizing. Let us discuss about the diffusion coating or surface alloying. The part to be coated are packed in a powder solid metal or exposed to gaseous atmosphere contain the metal, and that to be coated, and high temperature treatment causes the diffusion and may form an alloy. So the shearodizing, that is zinc, chromium, calorizing, anodizing, then ferrosilicon, okay, are the common example of this process. And these coatings are relatively thick and are usually applied to cast or machined parts such as halls, wall guides, and turbine buckets. Carbon steel, low alloy steels, and stainless steels are the alloyized product, and here a protective layer of aluminum oxide forms on iron aluminum alloyed surface. Okay, now let us discuss the last, that is the cladding. So this cladding is a joining of the two different metal or alloys by forming a strong alloy bond between plates of the two metals, and the bond may be formed in many ways. For example, by casting one alloy against the solid plate of the other, and this thick composite ingot is then hot worked to reduce its useful form, such as clad sheet, a 1/8 inch nickel and a 1 inch steel sheet are hot rolled together to produce a clad sheet. Okay, and the cladding is usually thin than the other metal. Production of the corrosion resistant surface is the principal objective of this cladding process. And for example, alclad is to provide corrosion barrier to high strength aluminum alloy, which is with the commercially pure aluminum skin on both sides by rolling, because the alloy is susceptible to a stress corrosion. Okay, nickel, aluminum, copper, tin, or stainless steels are used for as a cladding for the steel, and it is very cheap method for protecting against the corrosion. And the cladding is also useful for such purposes as making bimetal strips for temperature control devices. Okay, so this is about the second part of the metallic coating. Okay, thank you very much.